Well, hello there. This is Mr. Boyce, and we are going to go over our lab today. So our first reaction is going to be silver nitrate reacting with copper. Now, obviously, we're not going to react the entire penny. Even if we did, it's mostly zinc, but it is copper plated, so the copper will react with the silver nitrate in a single replacement reaction. Pay attention to the products on your screen. Copper 2 nitrate, remember copper 2 is the charge of the copper, so be sure when you put it together that you put it together in the correct order. So you're going to have 4 different reactions here, and your job is to use the amounts that we will be giving you throughout the lab to start with your given measure quantity and find out the amount of product that you are going to be making. In some cases, you are going to be finding theoretical yield, and in one case, you're actually going to be taking actual yield compared to a theoretical yield for a percent yield. Okay, so for this reaction right here, obviously we cannot react the entire penny, and so we're going to give you some theoretical numbers, and those are coming up shortly. Okay, and so for the silver nitrate, what you're going to do is run your math with 10 milliliters of silver nitrate. That's 10 milliliters. Now remember to go from liters to moles. You need to be in liters, so convert that 10 milliliters. And for copper, we're going to assume you have 3.5 grams of copper. So you are going to do your math twice to find out how much copper 2 nitrate that you produce. Once you find that out, compare the two. Whichever one makes the least, that is going to be your theoretical yield. So just work that out with stoichiometry and mark down. So here we can see after the reaction has been going for a while, you can definitely see the chemical reaction. All right, next is magnesium plus oxygen. So this is going to look very much like a combustion reaction, and it is, but we still have magnesium reacting with the oxygen in the air, and that is going to be creating magnesium oxide. So this is a synthesis. Be careful when you write this reaction out that you pay attention to things like diatomics and swap drop for the recombination. For this one here, you're going to use 0.05 grams of magnesium. Okay, next is your double replacement reaction. So 3 milliliters of sodium iodide. And so you're going to write that out. So here we have 3 milliliters. And next, we're going to move on over to the other side of the table, and we're going to go and put some lead 2 nitrate. So remember, the 2 is the charge. So when you write this formula out, you're going to do a double replacement reaction, figure out and balance this reaction, and run both 3 milliliters of lead nitrate or lead 2 nitrate and 3 milliliters of sodium iodide. Okay. Now what I'm doing here is I'm measuring my filter and my weigh boat. So this gives me my initial weight, and I've already put together my chemicals, so I'm going to pour those onto my filter and let the filter dry for a while to try and get as much off. Now, a side note for this lab is the filter did not dry anywhere near enough. We'd probably have to let it sit for a few days to get a good number. So the percent yield, the mathematical yield versus what you're about to see on the screen. Now remember, this number, you need to subtract the empty weight of the filter and the boat. But you will find that you have a very, very, very high percent yield, and that's fine. This last one is the combustion of CH4. So just remember, CH4 plus O2 forms CO2 plus H2O. For that one, you're going to go ahead and balance that out. And that's all you have to do with that one is write it out and balance it. If you have any questions, please let me know. Thank you.